welcome back to the course. Today we'll be creating an AI handler which will function as the brain for our little AI. We'll be going over a simplified version of the state machine pattern, which we'll be using to create our patrolling behavior. Then in the future we'll be turning that simple state machine into something much more complex. Now the question is, what actually is the state machine pattern? Now a small description is state machines are incredibly useful. They're a really solid way of creating an AI that has to make kind of decisions based off of context. So let's take a look at my favorite tool, the flowchart. Yes, we will never escape flowcharts. So right here you can see that I've got this little flowchart set up for this charging enemy. Now this kind of goes through its states and how its brain will work, or how it will kind of function and make decisions. So the ready function fires. I'm going to kind of just go through this one at a time. The ready function fires, and then it enters what's known as the idle state. Now, the idle state will basically play a little idle animation and do some little things where, that can be considered idle. And then a random timer will go off. It will enter the wander state. It will start moving around a little bit, playing the moving animation, and then it will either come to a stop and then go back into idle, or it will come to a ledge and then make a decision based off of if it wants to keep moving in that direction, and if it does, it'll enter the jumping state. And then after it's done with the jumping state, it'll either go back to the idle state or go back into the wander state. Now that's just 3 states, and that controls a lot of different types of movement and kind of gives an AI a little bit of, or like an enemy, a little bit of life, right? Because it's all kind of decision based and random, which is cool. Now, you'll notice here that I've got these arrows that actually go between them. These arrows tell you, from this one is a really good version of this. If we go from the wander state to the jump state, we can go back from the jump state to the wander state. Or we can go from the jump state to the idle state. But we cannot go from the idle state straight into the jump state. Now, as we get further down this, you'll start to see some kind of interesting things. If we go back to the wander state here, so we go into the idle state, we start wandering around, and oh no, a player enters our view, right? So the enemy's going to have like a radius. If the player enters it and it notices the player, it will then go to the chase state and it'll start chasing the player down. Now, from the chase state, it can either run into the player, it can die, or it can go back into the wander state. So if it loses focus or loses view of the player, it goes back into the wander state. If it runs off of an edge or the player kills it, it dies. But you'll notice here that this chase state doesn't have any connection to the jump state. Now, why is that? Well, charging enemies, or this type of charging enemy concept that I've come up with, is like a wild boar. Once it starts charging, it cannot stop or do anything else. It needs to finish that charge, which means it gives the player a little unique way of killing this, or destroying this enemy, by getting it to run off of ledges or run into something. And that's kind of why and how this is designed. So the player can beat it by using weapons, or it can beat it by using itself against it. You'll also notice from every single one of these states, it can go into the death state. And that's because we don't want to have any state that makes the enemy invulnerable. We could make another enemy that can go invulnerable by adding a invulnerability state that every state can go into to heal or something. That's kind of how state machines work. It makes decisions based off of context. From idle state to wander state, for example, is a random timer will fire. It will go, okay, fire a random timer, and then 50-50 chance, like a coin flip. If it lands on that wander state, go into the wander state. If it doesn't, keep it to the idle state. And if it does, from the wander state, it can make more decisions based off of which direction it's moving, or if it comes across a ledge, or if it sees the player. And the same thing goes from the idle state to the chase state. You can go from idle to chase, and then chase back into idle, based off of if it sees the player or loses focus of the player. And that's kind of a really simplified version of a state machine, but it's a really cool concept to kind of get a good grasp on. And there is a lot of different reading material about state machines or finite state machines out there, and I would really suggest taking a good read of those if you really want to learn how to create some really unique and interesting AIs. And I think I said this before, but in the previous video, that one of the most interesting AIs I've come across is the Alien Isolation Alien AI. The AI that they actually use for that is intuitive, and it learns based off of your patterns, which is really cool. And we're not making anything nearly as complex as that. What we're going to make today, if I come over to the right here, is our patroller enemy state machine, or our patroller enemy AI. It's going to have three states. It's going to have the moving left state, the moving right state, and the DESC state. The DESC state is one we won't have to focus on for now because we don't have any way of implementing a DESC state. We'll have this eventually, but this is how it's going to work. On ready, it's going to pick moving right or moving left. We're probably going to start with moving left, and then it will keep moving left until it finds a floor or a wall. When it does, it will then change directions and start moving right. And then, once again, if it finds a wall or a floor, it'll do the same thing. And you kind of just have this loop. This kind of just creates that patrolling kind of status, where it goes from left to right until it hits something, and that's it. It'll just keep doing that. There's no chase states, there's no other states, and that is because when you want to start building something like this, you're going to want a much more complex state machine. And one of the coolest things I haven't kind of talked about with this is when you create these states, you're going to have to create their own code. And that's where the power of state machines really kind of come in, is when you are in the moving left state, only the code in the moving left state runs. So you're setting the enemy's velocity here in the moving left state so it moves left, but you're in the moving right state, you're setting it so it's moving right. If these were both around at the same time, it would either freak out or it would do nothing. That's why we use state machines for stuff like this. Now, let's actually move on to kind of implementing this stuff, but there is one thing we need to do first, and this is kind of the most spooky thing. This is a big scary word that you'll hear quite a lot, and it's known as the dreaded refactor. We're going to be refactoring our movement handler and our input handler so it can be more widely used across our project. This will be the first of many refactors that we do as we expand our knowledge and our project, but it's something you want to get used to as you go, because as your project grows, more and more complex code is kind of required, right? And you only kind of learn that complex code as you keep learning, and then you'll end up refactoring. Working on my primary project, I've done quite a few refactors to increase the kind of scope of the game, which not entirely always a good thing, but is something that you kind of just end up doing. And not everybody likes it. I find it kind of relaxing to refactor code. A lot of people find it quite tedious. Really down to the person. So let's actually start this refactor, and we're going to start off with the input handler. Now, why do we need to change our input handler, which is connected to our player entity? Let's open up the player entity scene. You can open up scenes individually by clicking on the little scene icon here, if they're like in a tree or something. But yes, why do we need to refactor the input handler? Well, to be very blunt, the input handler feeds directly into the movement handler. If we open the movement handler script, right, the movement handler is taking an input direction which is a floating variable. To make it easier on ourselves, we're actually going to want to use a vector typed variable, not a floating variable. Now, the issue that comes with this, and this is why it's kind of a refactor, is if we go into our input handler, this returns a floating variable. So it won't work or it won't match up, which means either we need to come up with an entire floating variable related method for moving our enemies, or picking a direction, which, you know, we could just use -1 and 1 if we really wanted to, or we can kind of expand upon our input handler a little bit and our movement handler to make it a bit more complex but a bit more usable system-wide. So we're going to start with the input handler. To do that, we're going to need to change the handle movement input function. First thing we're going to want to change is the float. We're going to want to change this to a vector2. Over the first or second episode, when I started explaining some GDScript basics, we kind of covered vector2s. We'll be covering those a lot more as we go through the course. Vectors are extremely important. Now, we're still going to want to return something from this, but we're going to want to return vector2. So to stop getting an error, I'm just going to write vector2.0. Now, a vector2.0 quite simply looks like this. This is what a vector2.0 is. It's a completely zeroed out vector2, which means it literally contains no specific coordinates, directions, or anything in the x and y. So that's all we're returning, and just using .0 is just a kind of faster version of writing out vector2. So what we're going to want to make now is a variable inside of this function. So this is going to be a localized variable inside of the function, so nothing else can actually modify or touch this function, or this variable. And that's going to be for a var, and we're going to call it the movement underscore direction. This is going to be of type vector2, and then we're going to set this one also equal to a vector2.0. And that's just us presetting the movement direction, so there is nothing being pressed. So it's just storing as nothing. Now we'll add a couple of lines here, and we need to now actually apply some numbers or some actual data to this vector, right? We need to actually get it so it's now applying our left and right. And we can use the same method we used before, but instead of just setting it as a float, what we can do is we can write the movement direction dot x, because we want to set the x, and we want to set that equal to the input dot get axis, and then we're just going to get move left and move right. And what that's going to do is in the x value of our vector2, we can look at this real quick by just pulling up a vector2. We can see here vector2 from vector2 to I, and then at the very bottom here, so a 2i is a integer specific vector2. We won't go into that just yet, but at the very bottom here you'll see the x and the y. So the left side number is the x and the right side number is the y. We're basically saying we want this right side, we want the right side to be 0, and we want the left side to be either -1, 0, or 1, depending on what our axis says, because remember, input.getAxis will return a floating variable from left being -1, and then 0 for nothing, and right being 1. So that we're kind of doing a similar thing, but now we're turning it into a vector, and that's really important for when we want to do vector-based math for a lot of our entities in our AI, basically things that aren't controlled by our player. And now in the return method, all we have to do is return the movement direction. So we want to return the full vector2 here. We'll hit Control S and make sure that's saved. We can go into our game and make sure that this is actually running, but remember, we haven't changed anything in the movement handler yet. So let's go and change that. Let's go and change specifically, if we go and look at the handle movement function, so we're passing in a character body, that's normal, we want that. And then we want to go and change the input dir to a vector2. And the best part about this type of refactor is we don't actually have to change much. We can just change the input dir, and we can put a dot x at the end of it. So what this is going to do is we want to check the vector2 of the input dir, which has an x and y, and we want to check the .x variable. And that way we can set our speed based off of the same parameters we used before, but we're using a vector instead. So we can do .x on both. Hit Control S and save. Now we can run the project and see how it runs. And you can see we are still doing the same things. We are still moving left and right, everything feels normal, and yet it's just a little bit more complex because we're using a vector now instead of just a normal floating number, which is great. Now, with that one done, there is one more thing I really wanted to change in this. I'm going to close the movement handler and the input handler. I'm going to open up the player script here, and I want to come down and I want to remove this apply gravity function out of the player, because I don't think the player should be in control of its own gravity. I think another handler should be in control of its, of the actual gravity itself. That way we remove some variables like this. Now this 600 number we're going to keep in mind, but this function here, we're going to hit Control X and remove as we highlight the whole thing. That way we copy the whole thing, or specifically cut the whole thing. Now we're going to remove the function call for it within our physics process. Hit Control S and save. We're going to go and open up a new scene. We're going to make this scene a 2D scene. We're going to call this the gravity handler. Control S and save this under scenes, under handlers. This isn't player specific, so it can just go into the kind of outer folder here. I'm going to go give it a script of gravity handler. Give it a class underscore name of gravity handler. And simply put, all we can do now is just hit Control V and paste in that function that we cut out. Now it's going to throw back some errors because we need to modify this a little bit and make sure it runs perfectly. Now to do that, all we need to do at the very start here is add a new parameter variable for the character underscore body, and then set that equal to the character body 2D. Like so. Now that will basically give us access to whichever character body gets passed in here. And then for our if statement, at the is on floor check, we can, at the very start of our if, we can go character body dot, and then that will grab the character body dot is on floor, which we have or we want to use anyway. And then we can do the same thing to the velocity.y. Velocity.y, there we go. Oh, and we also need to have a variable for gravity. I'm going to make this a constant var, or just a constant in general. We're going to call it, in all caps, gravity. I'm going to set this equal to a float, or set it as a float, and then I'm going to set it equal to that nice round 600 number, and I'm going to put a decimal and a 0 at the end of it to make sure it's rounded out to 0. I'm going to change the lowercase gravity to the uppercase gravity to make sure it's calling the correct thing. Hit Control S and save. And now that is our apply gravity done in a bit more of a different way, where now all we're going to have to do inside of anything that counts as a character body that we want to apply gravity to, we're just going to give it a gravity handler and then allow it to call that apply gravity function and go from there. So let's do that with our player entity, because if we play the game now, our character, here, let's go and show it off a bit. Our character is just going to be floating. It can't do anything, it's just floating. And we don't want that. We want it to actually fall to the ground because gravity is a thing. So we're going to create a new onReady variable here. Well, we're going to add our gravity handler first. We're going to highlight player entity, hit Control, Shift, and A to add. And then we're going to grab that newly created gravity handler and place that into our entity tree here. I'm going to pull it across, hit Control as we drop. That'll create the onReady variable. Then I'm going to typecast this as the gravity handler. And one thing that I never really talked about is how onReady variables kind of work. And that comes down to this function here, the ready function. Truthfully, what you can do is you can go, I'm going to give this an underscore. I'm going to go var underscore gravity underscore handler. And then I'm going to typecast this as a gravity handler type. And then I'm going to set it equal to null. And you'll notice that, well, there's nothing here, so this won't do anything. But in the ready function, what I can now do is I can call gravity handler, then I can go equals, then I can use the $sign accessor, which will basically access the entity's tree here and see what's inside of this, or the node tree, so we can see what nodes are there. And then I can just call the gravity handler like so, make sure that is named correctly. And this is pretty much the same as using an onReady variable. Now, I don't like cluttering up my ready function, so I prefer to just use an onReady and kind of do it like that. The other way, of course, is creating an export var for the underscore gravity underscore handler. Typecast it as a gravity handler, set it equal to null. Hit Control S and save. And now if I go to the player entity, because of how the typecasting works with the export variables, this will now only accept nodes of the type gravity handler, which is why it's highlighted. I can't add a flip handler or jump handler or a movement handler, but I can add the gravity handler. And this basically will once again give us access to our gravity handler. So I can go underscore gravity handler dot apply gravity. And we get the autocorrect and the complete functionality of it. This is another great way of kind of setting up a lot of different components, but sometimes it injects a bit of a dependency that we don't entirely need for everything. We will need that for certain things in the future, and I will go through those when we get to them. So now we have our gravity handler ready. We can now go and apply our gravity, and we're going to do that at the top of the physics process function. So we're just going to call the gravity handler. Then we're going to access it with a dot, and we'll use apply gravity. We're going to pass in the self keyword, because that's the player entity, or the character body that it is. And then we're going to pass through delta. Now I'm going to hit Control S and save. And I just want to say this, the reason why we're using a const, or a constant number instead of a exported number, is because we know that 600 is the number that we're most comfortable with right now. This means that we don't have access to edit the gravity within the script, and nothing can change this number. Constants cannot be changed. They are forever this specific number. We can only change them outside of the game when we're in the script itself. So I've settled with 600. I feel like that's comfortable. I may change this in the future. But another really good benefit of having this gravity handler sorted is when I change it in this script, it will change it for everything else that uses the gravity handler. So let's go and press play. Our character now falls to the floor properly, can jump properly, and everything's back to normal. Good. So that's everything that we needed to set up, every little refactor we needed to actually set up. Now, we're going to go and move into the AI handler. We're going to set up our first little state machine and kind of get it running, and I'll walk you through why, or at least how you can kind of code state machines in a simple way. I use a certain type of state machine when I'm creating prototypes, and I will show you what that is now. We're going to create a new scene. We're going to create it as a 2D scene. You don't need to always do 2D scenes. Now, this is a big thing. Node 2Ds cost more resource than a normal node themselves. That isn't always a big deal, depending on how large your project is. For something as small as our project, we don't really need to always worry too much about how many types of nodes we're using depending on the resources, because it's going to be tiny. But say for an open world game, you're going to need to really pay attention to what nodes end up paying or needing more resources to do certain things. In this case, node 2Ds will be more than a normal node, but we don't really need to think about that right now. In future, I might do like a little open world game where we go and like optimize it and make sure it runs fine, but for now, no worries. We're going to rename this node to the AI handler. Hit Control S and we'll save it. This is an enemy specific handler, so we're going to create a new folder in our handlers folder, and we're going to call this the enemy folder. Now we're going to add a script to it for AI handler. Hit create. Going to give it a class name, AI handler. There we go. And now we need to actually give it a few exported variables. And this is kind of what I was saying just a second ago about why we like to use exported variables in certain ways. We're always going to want certain things on our handlers, or on our AI handler specifically. And if we don't want them, we kind of need a way of saying we don't want this, that's okay, and it won't break anything. Now, we're going to set up the export variables first, and I'll tell you kind of why we need to use these. So we're going to use an export var, and the first one is going to be for a floor underscore check, and this is going to be for the left side, so floor check left. Then we'll use a colon. We're going to typecast this specifically as a raycast 2D. Then we're going to set it equal to null, so it won't error out if there is, nothing there. And then to speed this process up, we can copy this whole line, hit Control C to copy it, and then we can paste it with Control V, and then we can change floor check left to floor check right. Now, if we go back down into our file system here, go into our scenes, our enemy, and our enemy patroller here, you'll remember we created floor check left and floor check right as part of this specific patroller enemy. And that's good. We need these specific checks to stop it from falling off of a ledge. But the question becomes, what happens if it collides with a wall? As of right now, it's not checking if there's a wall next to it or not, so it's just going to keep walking into the wall because there is going to be no state to change that direction or nothing to check if it needs to change. So to fix this, we're going to go to our floor check left in our little patroller scene here. We're going to highlight it. We're going to hit Control D to duplicate it. We're going to rename floor check left to wall check left. Going to remove the 2 at the end of it because that's not necessary. And we're going to do the same thing to the floor check right. We're going to change this into the wall check right. Remove the 2 at the end of it. Hit Control S and save. Now we have our 2 checks. We need to just make sure that they're looking in the right directions. We can just drag from this little dot and get them to move into the right directions. Now, one thing you can do to make sure that they are all kind of equal size is you can click on it, and then you can see the target position here, -11. I'm going to move that down to, let's go a little bit more. Let's go -8. So -8 on the left side, which will mean this one will be 8 on the right side. There we go. Hit Control S and save. Now we can go back to our AI handler script, and we can now add some more exported variables for these. So to do this, I'm just going to hit Control C to copy the exported variables we've created for the left and right wall checks, or floor checks. Copy them, paste them, and I'm going to rename them to wall check left and wall check right. So we now have those set up, so we can set them in the AI handler here. Now, one final one we're going to want, because this is the AI handler, it's going to handle the brain, this is the brain. We're going to also want exported variable for a movement underscore handler. And we're going to typecast this, of course, as a movement handler and set it equal to null. I'm going to hit Control S and save. I'm going to go back to the patroller enemy. I'm going to highlight the patroller enemy's root, which is the character body 2D. Hit Control Shift A to add, and I'm going to add the AI handler to it now. Now I'm just going to move this up. Now, one thing you always want to keep in mind when you're kind of composing your scene here is actually how you've got these laid out. So if I go to the patroller enemy and I added a script to this, there is a function, there's also a signal in here for the ready function, or the ready signal. This fires when all of its children are ready. And how does it know when they're ready? Because all of these children, when they actually are ready, will fire a ready signal, and then this will go through them all, make sure it's all set and ready and done. That's a kind of really basic explanation of how it works, but it will basically go from top to bottom, or from bottom to top, and it will go through like that. So if we want to add these checks into our AI handler, we're going to want to make sure that the AI handler is above the floor checks left and right. So I'm going to now put that there, which it is. I'm now going to actually put it above my movement handler. I'm going to pull the floor check, actually. We'll go over to here, floor check left, hit assign, floor check left, floor check right, hit assign, floor check right, wall check left, here's wall check left, and wall check right, and then finally the movement handler. Now we can hit Control S and save, and we now have access to all of these things on the AI handler itself. You don't need to assign these immediately after you add them in. You do need to assign them in general, but when we're working on the script, they don't actually need to be assigned for any real reason. I just like to get that sorted so you can kind of have it done. Now let's move into the actual state machine for this. We're going to be using a really simple state machine, and it's known as an enumerated state machine. The eagle-eyed of you may have noticed that when I was showing off this, I actually have the words basic enum sm here, which stands for basic enum state machine. An enumerated state machine is going to be what I like to call the state machine for prototypes, or smaller games. It's a little bit of a weird concept to follow for an enumerator. You may want to just go and check it yourself. I will put a little description in the or a little description for it in the description if you would like to read that as well. But to set this up, we're just going to write enum, and then we're going to open some squiggly braces or some curly brackets. Now in here we can put our individual states in. Now I'm going to be using capses or full uppercase words for this. So it's going to be move underscore left, and then one more for move underscore right. Now, the reason why I'm doing this is because eventually this is going to get removed. We're going to be using something different. But for now, this is going to function the way we want it to, and we want to make sure that the states kind of pop out. So these are our states. These are what our behaviors are going to be. Now, we want to move down 2 lines, and we're going to create a new variable. And this is going to be for the current underscore state. And then we will preset this to we'll preset it to the move left state. Now we need to define what behaviors we're going to be using for move left and move right, or what we need to do when we're in these current states. Now to do that, we can do something really simple. We can create a new function. We can call this the handle underscore state function. It's going to end up needing to take in delta, which we always know is a float. But it's going to have a return type of void because it doesn't need to return anything. I'm going to create some new lines in there so we can enter the function itself. And we are going to be using a match statement. So match statements are really simple. You write match, and then you write the thing that you want to match specific things with. So in this case, we want to match the current state variable. And then you use a colon to cap that off. Now this is kind of like in gaming terms, an overpowered if statement. Match statements are a little bit faster and a lot more expandable than if else and else if statements, or if else if and else statements. So I prefer to use match statements where I can, when I can, but if statements really do have their places as well, and we'll be using an if statement or if check in this too. But for now, we're going to be using match. So what do we want to match current state? Well, we want to match what it actually is. So is current state going to be set to move left or move right? Now to do that, all we have to do as we've entered the match statement is check move left. Because what this is going is, okay, we're checking current state. What is current state equal to? Is it equal to move left? And in this case, if it is equal to move left, we're going to want to do something. For now, I'm going to write pass. And then we go down a line, we hit backspace to remove some indentation so we can be on the same line as our move left. And then we want to check if it's also on move right. And then I press pass. So what this is going to do, if I separate this a little bit so it's easy to see, give some new lines here. There we go. What this is actually going to do is it's going to go, okay, is current state move left? If it is move left, do thing. If it's not move left, ignore this code and do this. And it can only ever be move left or move right now because we haven't added any extra states to this. So this is what it's going to just be, left and right. Now, what do we want to do when we're in here? Well, we're going to want to grab the movement handler, and we're going to want to kind of activate the movement for the parent specifically. Now, we don't have a variable preset for the parent, and that's not entirely a bad thing. We will get to the issues behind that when we do probably our next refactor. But for now, we can call the handle movement function. We need to pass in a character body. So as said, we don't have a reference to the character body. We don't have a parent or anything along those lines. Now, you can put the parent up here. You could do the character underscore body, and then once again, set it equal to a character body 2D. And that functions pretty much as we want it to, because we can then just pass in the character body 2D. And then we can, go about what we want to do. Or what you can also do if you don't want to just use, if you don't want to hard-code it be a character body 2D, you can use, let's say, get underscore parent. Now this can be dangerous because, as said, if it's not capable of having a velocity, then this will not work. This will have issues. But this is how you get the parent. So we're just going to use that character body 2D. So character body here. So character body 2D, pass in character body. We then want to pass in a direction. So if we are moving left, we're going to be using a vector2 dot, and just as I said, vector2 0 exists, so does down, up, left, and right. So we're going to be using vector2 dot left, and then we'll pass through delta. Now we can remove this pass statement because we won't need it anymore. And then we can hit Control-C, copy that, paste it into the move right, and then change the vector2.left to vector2.right. And that is the logic that we need for our states. Now, this is great. If it's in the move left state, which it will immediately be, it's going to immediately start moving left. That's perfect. We want that. But how do we switch between the two, right? There's nothing here saying, okay, go from move left to move right. Now, easiest way of doing that is to create another function. We're going to call this the check underscore state function. It's going to have no parameters, and it will be a void return type. And now we need to do two if checks and there can be kind of some odd if checks when we do them. So we'll do the first one. We'll go if. We want to check if the floor check left dot is colliding function. That's part of a raycast function. It basically just returns true or false if the raycast is colliding. And what we want to go and say is if the floor check is no longer colliding, which means there is no longer floor there, we want to do something, which means we need to set this equal to false. And then we're going to use the OR statement. The OR statement in an if statement, or the OR keyword in an if statement, basically says check this or check this. If this evaluates to true, check this. If this evaluates to false, run the code. And vice versa. If this evaluates to true, run the code, or false, don't do anything. Now, the reason why I'm kind of flipping on false and true when it comes to these two statements is because we need to check opposite things. We need to check if the floor left, or floor check left is colliding is equal to false, because if it is colliding, we actually want to swap our current state. And then we want to check the wall check. And we actually want to check if this is colliding. So if is colliding, meaning it is equal to true, which we don't need to add the equal to true here. So if the floor check left is no longer colliding, run the code, or if the wall check left is colliding, run the code. If this first one evaluates to true, do nothing. If the second one evaluates to true, or false, sorry, do nothing. Sorry if this is a bit confusing. It's some weird logic, but it functions. So now what we've got to do in here is set our current state equal to the move right state. And since I can't spell check, apparently, there we go. Since we've got the state now changing from left to right, we now need to make sure it changes back. And we can apply the exact same logic here, but for the right checks for both the wall and the floor. So you could copy and paste this. It's a good idea sometimes to really kind of hammer out and get used to typing these things out to make sure that you kind of remember and like let that information sink in. So we'll just use is colliding, we'll set it equal to false, or the wall check right dot is colliding, there we go, do that, and then set the current state equal to move left. So we now have our logic. If the left side is no longer colliding, so in easier words, if there is no floor or there is a wall in our way, move right. And once again, do the same thing, but for the opposite state. And now to set this up correctly and get this running, we need to set this or use this or call this function before the match statement that we're running through. And to do that, all we have to do is just call check state. And we're done. This is a really, really simple version of a little patroller behavior that is ready and set up, and we will expand upon this greatly with a different type of state machine in the future, but this will do everything we want it to do before we can move on to the next part of our project. But, of course, we need to go and make sure it works. Well, we don't have any way of calling this yet, so let's go to the patroller enemy. Let's add a script to it. We can give this a class name of class underscore name, give it the patroller enemy name. Now we want access to the underscore ready function. I'm just going to write pass for now. Then we want access to the underscore physics process function, and I'm going to write pass because we need some onReady variables. Now we're going to need one for the AI handler, typecast as AI handler. There we go. We're going to want one for the movement handler, even though we won't be putting the movement handler to use in this code just yet, because we're using it in the AI handler, but we'll create a variable for it just in case. And we're going to want one for the flip handler. I forgot to write flip at the start there. There we go, flip handler. And that's nearly everything we need to do. Now, if we remember correctly, the flip handler, what I can do is I can hold down Control, click on the flip handler class, and it'll come into here for us. We need access to a sprite.2d in here, and if we don't have the sprite2d variable, then it's going to have a heart attack and not do anything. This is a bit of a issue, which we can handle in the future, but for now, because we know that, we can come back to our patroller enemy. We can drag across our sprite2d, make sure it's named sprite underscore 2d, like it is here, hit as, and then set that to a sprite2d. So, with those done, we can now start kind of calling things. One thing I forgot actually is gravity handler. We need to attach a gravity handler to this. Now, if you've been following along and you went and sorted out you kind of went through the inheritance episode and you have a base enemy class set up, I want you to kind of think about how we can make sure that every single enemy that we inherit from that can have the gravity handler, like the flip handler. And then I want you to go and do that. So pause the video and just go and give that a try and see if you can figure that out. And of course, if you can, I'm going to go through it now and I'll show it off a little bit. So we're going to go to the base enemy.tscn. We're going to highlight it. I'm going to hit Control-Shift-A to add. Then I'm going to add a gravity handler to it. Then I'm going to hit Control-S and save. Close out the base enemy entity. And there it is. It's now in the gravity handler. Now, I want to move these floor checks below that because I want the floor checks to always be at the bottom of my script. And that's it. We are set and sorted. We just need to add a onReady variable to the gravity handler as well. Now, one thing to keep in mind is I said that we can go through a thing called inheritance via the class and the script as well. And we could actually set it up so a lot of this stuff is already preset and done within the scripts. For now, we don't really need to worry or think about that. That's going to be happening when we kind of create a much larger version of this game, or we move from prototype to the project itself. And since we're in prototyping phase, things can be a bit loose, which is fun. So, in the physics process, we're now going to want to start calling our things. We want to start, of course, calling the gravity handler. We want to apply the gravity to our character. We're going to use self as the first variable, pass through delta. And then we're going to want to apply our AI handler and actually get that running correctly. So AI handler dot, we want to do handle state. Then we want to pass in self and delta, like so. And now we can call our flip handler as well. Dot handle flip, pass in self. And the other thing we can do is, of course, we're going to need to use the function for move and slide. And we'll hit Control S and save. And that pretty much sets up our patrol enemy. So let's go through. We'll click the gravity handler, or we'll click the AI handler. This is a really good habit to get into when you put things into your scenes. Sometimes you forget to set things up. So we'll go through the patrol enemy, make sure there's nothing up here to set. The AI handler, everything is already set for that. Movement handler, see, problem immediately. We don't have a movement speed set up. Well, our base character's movement speed is 6,000 units. For our patroller, I'm going to do 4,000 units. It's going to be a bit slower than the player, so our player can outrun it, and that's fine. It's just supposed to be a little enemy that can be kind of annoying. Our flip handler has nothing, our gravity handler has nothing, and our checks are all set. So let's hit Control S and save. Let's go back into the main scene, and now I'm going to go and add a patroller enemy to the scene by just dragging it in and dropping it on the floor. Now I can hit play, and we'll get to see if it runs. And it's doing its things. It's being a little bit confused, and it's kind of showing off an interesting behavior. Right now, the movement seems to be affected by how the character is moving. So I'm going to be right back and figure out why that's oh, that's why. Never mind. I have managed to add that to the player entity. We don't want it in the player entity, or a child of the player entity. We want a child of the entity container. That was nearly a 2-hour debugging session of me being confused. And there you go. We can see it hit the corner and now it's moving. And this is a really long platform. So what we can do here is go and modify our test level a little bit and give it some other platforms to walk on and some walls to bump into. Now, if you remember how to do that, feel free to go and do that now. I'm going to come up here to the test level, hit the scene, tile map, come down to the tile map button, pull this up a bit. Make sure to go into the paint mode and have the selector up here selected, so you're actually using these buttons down here. If you have this selected, it won't let you do any painting. So I'm going to go here, I'm going to add, let's say, a little bit of a gap here. We'll do like a 3-block gap. I'll also go up here with this block, which is, we'll grab this block. This is a corner block here, and then I'm going to add a corner block here. Is that too high? No, that'd be fine. Add some flooring to this, and then add the actual flooring here. Come down, add some sidings. Add a corner there, get a bit artsy and fun with it, and there we go. So we now have some platforms for us to kind of bump on. I'm going to do another small little divot or hole here, and just because I find it very funny, I'm going to create another little one here, and I'm going to place a little guy here. So I'm going to hit Control S and save. Go back over to main, and you'll see that new changes have been applied. I'm going to click on the player entity. I'm going to pull the player entity down closer to the floor, and then I'm going to grab the patroller enemy. I'm going to put this one up here, which you'll notice the camera cannot completely see yet, and we'll fix that in a second. So I'm going to hit Control S and save. I'm now going to go and duplicate this patroller enemy with Control D, pull it down to here. Once again, duplicate, Control D, duplicate, Control D, and duplicate with Control D. And there we go. Now I'm going to hit play, And you'll see this one's freaking out because it doesn't know what to do because it's always colliding with no floor. This one is doing its thing. This one fell through the floor because there's no collision down here. We can push these off the ledges. And this one is actually having a good old time just colliding with walls. And that is how we set up our first player, or our first little enemy with a little behavior for the patrolling. And I hope that this has been like kind of useful and helpful for you to learn. Now, one thing that I'm going to tell you is you now technically have enough knowledge to go off and start creating your own little prototypes and your own little games with just this. You can go off and do that now. But there are some things that we haven't covered yet, like the UI specifically. We need to cover some UI stuff, and we'll cover the other systems like an upgrade system and the karma related system. But I wanted to let you know that you've done really well so far. You're doing absolutely amazingly. And yeah, that's pretty much it for this video and this part. I hope you have enjoyed. I hope you're having a good day and a great game dev journey, and I will see you in the next video.